So a geospatial revolution is on the way, and we need to kind of realize that, but it's really tricky because, you know, there's a lot of issues with sensor interoperability and data readiness. We need to make that ready. And there's been a major revolution over the last years, powered by new observational paradigms that kind of promote a new way of observing the Earth, giving high cadence observations at very high spatial resolution. So the planet operates a flock of these kind of CubeSats and nanosatellites, and these are like the Beaujolais of CubeSats, of satellites. They have, they're cheap, they are young, and they provide decent quality in a concise format. And this kind of rise of the CubeSats is a game changer because spatial temporal resolution matters. But with coarse resolution MODIS images like this, it's really difficult to tell what's going on. Any guesses? You know, this could be basically anything. But with a 30-meter resolution Landsat, you know, you can start to kind of identify some of the features, but it's still a little bit blurry and is not able to resolve some of the intricate features of the buildings and road networks. But with a factor of 10 increase in resolution relative to Landsat, you know, CubeSats, you know, wow, they can really start to resolve spatial detail at a resolution that hasn't been feasible, you know, in the past. So really giving you additional detail at a very high temporal resolution. So basically, you're going to have observations on a daily basis at 3-meter resolution globally. And with this type of data, you can start to kind of resolve spatial detail and temporal dynamics at a resolution deemed unimaginable just a few years ago. So this paradigm shift from single mission billion-dollar satellites to constellation of cheap CubeSats really means that we are presented with unprecedented opportunities to derive usable insights. Yeah, but this doesn't come without challenges because data, you know, come from different sensors may not look perfectly the same. The NDVI from one sensor will not correspond to the NDVI from another sensor. And these kind of inconsistencies really makes it challenging to kind of derive useful analytics from the data. So, and that is something that needs a lot of work. So that's one of the things we're working at a Planet. And what we kind of envisions is this kind of next generation analysis-ready data. But first, another kind of things that kind of makes data less interoperable is kind of view and geometry of the sensors. Some sees the, you know, from very oblique view angle, whereas others sees it from an ideal-looking kind of observation strategy. And in addition to that, we have clouds. You know, they can kind of mess up everything. They're like the nightmare. And this geospatial data revolution can kind of sometimes feel more like a curse than a blessing, right? I hate those clouds. So what we envision is a next generation analysis-ready data where you kind of don't have to worry about these kind of issues. So serving the community a very clean cloud screen and gap-free data stream combining inputs from many different sources. And enabled by CubeSats and powered by machine learning, this system harmonizers will fuse these multi-sense observation to provide a very clean sensor-agnostic data stream that is aligned to a radiometric gold standard. And this kind of harmonization approach is visualized here, so we'll align any data to kind of the same radiometry. So any data from different streams will look virtually the same after harmonization. Yeah, and then this kind of shows you, you know, the raw data, so, and kind of highlights some of the challenges with that data. You know, you have gaps, you have clouds, you have brightness differences. It's like an epileptic attack, right? It's just a nightmare to look at. But with the system harmonized, we're kind of able to kind of clean that up and produce something that's pleasing. You know, it looks nice. You know, there's no gaps. You know, wow, it's beautiful. All right. So, and then we can take this kind of a daily feed of surface reflectances and turn it into a metric like NDVI to months of vegetation at superior and unprecedented resolution and confidence, and that can really kind of advance agricultural insights significantly. So when you look at a time series, you can also kind of start to appreciate the temporal consistency of a clean data set like this, how it compares to the original stream that is a little bit noisy, and then we can start to kind of position remote sensing as a very trustworthy source for providing usable insights. So basically, the take-home message is that using an approach like this, we can start to turn data from different sensors into a very clean, uniform stream, that aligns and that it has the quality of a Barola. So we're no more Beaujolais. It's just